All right, guys. Our next speaker is Ivan Shmidt. Welcome, Ivan. Ivan is going to be giving a talk on source maps, so stay tuned. I think you're also joining us in a few weeks, I believe. So we're very excited to have you. But yes, please.
1, 2. Yeah, cool.
1, 2.
I'm on.
Please help me give a warm welcome to Ivan Shmidt.
Hello, everybody. Thanks for being here at Vlq.js. Somebody may remember me from a couple of Vlqs ago. I was giving a talk about AST and code modes transformation. That was quite techy. This one would be as well, so sorry for that. Like we had one small problem. Oh yeah, sure. I'm Ivan Shmidt. I'm software engineer. I'm working currently, ending my working in the Nordnet and joining 0+X. Yeah, thank you. So I want to talk today about the debugging, the cornerstone of our profession. How many of you enjoy debugging? Okay, how many of you enjoy debugging in production? Okay, there was somebody, okay. But I mean, it's quite frustrating experience for us as developers because the code that we have to debug, it's not kind of the same code that we wrote, at least nowadays. And given this like React example, it basically a bunch of just some stuff that doesn't make sense. I didn't wrote it. I don't know actually where does it point. But it's not only a production matter, right? Because we have a lot of tooling around the JavaScript infrastructure. And for example, these 4 lines of code, given the proper left, will transform into 31. And again, guess where was the code that we wrote actually? So all that, again, is quite frustrating for us. And this is actually something that we're doing quite often. It's not only if something has like got down in production, but also when we are developing, given the Babel and Webpack and TypeScript, I mean, it's really hard to catch on. So this is a link that brings you to the list of languages that can compile down to JavaScript. It's quite a big list. That's a screenshot of the whole page. I tried to count them, so it turns out it's like around 3,500 of such languages, if I did correct request. Yeah, so the problem is browser speaks JavaScript and it speaks it from the very old times. Nowadays, it's not only JavaScript, some other languages as well, but mostly it's JavaScript. So, I mean, we really want this thing, right? We really want to debug the same code that we're writing, that we are accountable for. And again, yeah, as I said, like we have a lot of steps in our current pipelines to get the code all the way in the browser. So we need to somehow get the backtraced to the source code. So meet the source maps. How many of you knows like what is the source map? Okay, how many of you knows what does the source map looks like and why it behaves like that and how the browser like actually getting the source map and getting the original file? Number of hands. Okay, cool. I have the right target audience. So this is not a talk about actually like what are the source maps. There are quite a lot of articles and talks in the internet covering this. So I want to use this one as an example. We're gonna slightly do a quick overview. So let's say you have a source code like this, and you get the compiled version like this. Notice the last line, the comment. And then you have the source map, which looks like this, which is basically a bunch of JSON. So these are basically the 3 ingredients that you need for it to work. The way it works, like let's look closer in the contents of the source map. So you have version, which corresponds to the version of the specification. You have the names of the files that were assembled to get your bundle. Yeah? Yeah, of course. Yeah, looks better? Yeah, thank you. Then don't care about the names now. Then you have mappings, which looks pretty cryptic. We will touch that a bit later. Then you have the end file name. And then you have sources content, like the content of your sources file. So having that, your DevTools will be able to actually map using the source map like every line and column of your bundle to the original file. So what about these mappings? The source map specification uses something called Base64 Vlq. Vlq stands for variable length quantity. Nerd, yes. So it's basically a pretty efficient way to represent numbers in a string way. And again, browser operates well with the strings, like given gzip and everything. So that's again, it's already the 3rd revision. So that's pretty efficient. You can see like 1 million can be represented only like with small amount of letters. Of course, not the best efficient, but given the task, it's okay. So every like comma separated thing represents one segment, and that segment basically represents like, okay, you need to look in source file number 1, for example. You need to go look for line number this and column number this, and this is going to be your like original symbol. So there is a yeah, of course. Yeah, anyway, there is a tool in this article to play around like in the real world to see how they're actually mapping. We're not going to touch that. That's not interesting. You can look into that in your own time. But what we're going to do, we're actually going to discuss some recipes on how to cook the source maps, because again, I was talking around, and I think the most common pattern of using source maps is setting source maps true in the tsconfig, for example, which is not actually like 100% of what you can get. So let's again come back to this simplest example. So you have your source code, right? Everybody see the picture? Yeah? Cool. You have your source code, you produce source maps, you then ship the bundle to the browser, then you open the DevTools in the browser, the DevTools fetches the source map, and then the DevTools is the source of truth, and you can have all the code in there. So let's have a look. I have the source map HTML thing. I'm gonna show it quickly. So yeah, everybody sees? So that's a boilerplate HTML. It does nothing but injects this script on the page. And this script is just some stuff. But as you can see, there is this comment, right? And this comment brings us to this map file, which has some more information. And you can see the sources content is something like totally different. So we'll see, will browser allow us to execute this source map 1 HTML index HTML. Cool. So that's our example. Again, on the page there is nothing interesting, but here, if we go, you can see, like here we have all the sources available currently to the DevTools. You can see our index.min.js, again, the one that was actually like injected on the page. But you can see this one, and it says from source map. So it's not actually presented, but the DevTools is kind of represented it in its own virtual file system. So if you open this, we will see our the stuff that we put in here, and actually, like, it doesn't mean it needs to be the real code. You can put anything you want. It not only works for HTML, for example, but it also works for, guess what, CSS. Yeah, you can see it's CSS. So we have HTML, again, that only injects this line 7, the index.min.css file, and you can see it right here. It says background red. That's actually what we see here, but it has source mapping URL. And if we go again to index.css generated from the source map, we will see body background blue. Good luck debugging that. Yeah, but again, like super simple. That is not interesting at all. Question, like what if we do not open DevTools? Will the same magic persist? Will browser just know about the source map and download it and everything that we just saw? So the second example is like I have the same setup. I have only one script injected, but the script itself, it tries to throw an error, it catches an error, and then we will see the error stack appended to the body. So without opening the DevTools, we will see the stack trace. So how many of you thinks that it's going to be like a correctly backtraced to the sources file? Okay, nobody. Good. Okay. Yeah, but if we run it, not CSS. Yeah, exactly what all of you were thinking. Like, it's not going to be backtraced automatically. But of course, if we open the sources, we will see our like hacked source map again. So no, this not going to fly. Moving on, let's talk more about this setup. Like, how do we actually produce the source maps from the original file? So for the third example, I have a pretty basic setup of Webpack plus Babel. I think like it's mostly what we're doing nowadays. Of course, there are a lot of stuff on top of that, but that's like bare minimum. Maybe it's not Webpack, maybe it's not only Babel, but for this example, that's enough. So Webpack alone has like a lot of settings for generation of source maps. You can see like it's pretty huge and scary table. We're not gonna, of course, cover all of that. I mean, that's not the purpose of this talk. But there are some of them that marked production, yes. And that one should be interesting. So I wrote them down here. It's like actually 5 of them. We're not even gonna cover all 5. But let's see what happens. So right now, if I, yeah, sorry. So that's our index.js file, some modern ES features, and also like just a handler, event listener. And the Babel config will just use the Babel loader, and the Babel loader will just spring some presets on top of it. So if we run the Webpack right now, it will generate one file called indexbundle.js, which will contain some Webpack bootstrapping plus some Babel bootstrapping, and it will have some variation of our code. And you can see it's not so good, and it actually misses the linking that we saw previously, right? The comment of like source mapping URL. So this one does not have the source map, and if we try to open it in browser, nothing will happen. But then, if we uncomment one of the DevTool options, so for example, I will go for the source map, then it will be different. So now you have the .js.map file, .js.map, not joking. And let me get this. Yeah, you can see there are some stuff. First of all, it's Webpack bootstrapping, that's given. But then we can see the actual like source file name, and we can see all of the names of like variables and whatever you used that got minified afterwards. It's all in there, so we can get that back eventually. And then you can see the sources content, both for first goes for Webpack bootstrapping, and the second goes for your exact code that you actually wrote. So that's good. So already this step will give you like a really neat developer experience. But this is kind of expensive. Like you have all of your like source inside your source map, right? And if you are bundling not from a single file, it would be actually like a lot. So there are different alternatives. For example, cheap source map. So the difference is the source map will save both the information about the line and the column of every symbol. But the cheap source map will only preserve the lines. For stack traces, for example, that is pretty much enough. You don't need to know which actually column if you don't do one-liners, which I hope you don't. So the cheap module source map has slight changes, but it's pretty much about the same. They're only different about like, do you want the code already produced by the loaders, or do you want your actual code? Hidden source map and no sources source map are actually like super interesting, because what hidden source map does, it will generate a source map, full-blown source map, good developer experience, but it will not include the comment in the bundle. So the dev tool will not know by default where to look at. You can point it out yourself somehow, different system, we will cover that later. But yeah, basically nobody will get that. And there is no sources, source map. So if we uncomment that and we run it, we will see that it will generate the map, pretty much the same, but it has no sources in it. So that's quite like fast, and why do you need that? Right? Because the whole point was to be able to backtrack it to the source. Because, as I said, stack traces. For stack traces, especially if you are passing them to some other logging service, you don't actually need the sources file to do that. You just need to get the proper line and the column, right? So that's super fast. That's the fastest one. Okay, so moving on. What if we have not a single file, but like some files bundled together, and then we want to still have this beautiful experience? What then? So the setup is that we have bar, which exports one const, and foo, which exports one function, and then we have the index file that bundles them together. So we're going to generate the source map, and we'll see how that works. So it will generate the bundle.js, and we can see our beautiful comment in the end. But it also will produce the map, and the map will, in fact, include all of them, like all of the files. So again, as I told you before, it's going to get messy in this area because it's going to contain all of the source for all of the files. But it's good to know. The interesting one, what if we include some not modules, for example, like in a monorepo, right? And we want to have the sources of not modules as well. Is it even possible? Turns out, yes, it is possible. The setup is like that. So we import the hello world from the bundle that we just built in the previous example. I just put it in not modules test package. Nothing scary here, and we just want to console log that. The webpack config is a bit different, so it still generates the source map, but I added one more loader called source map loader. What that loader does, it will actually traverse your whole not modules tree and get every available source map. It has some configuration, of course, like you probably don't want to have the source maps for React or something like that, just for your code. But that is available to configure in here. So when I run now the build for our 3.3 example, you'll see that the generated bundle, yeah, let's see the bundle first. So the generated bundle has the source mapping URL, and the source map itself not only includes our 3.3 index.js, but the ones from the previous example as well. And it's all available in here. So that all works. That's cool, right? But not enough. Give me more. Okay. Debugging in production. So that's a bit more complex scheme. So let's say we have our source code, right? We generate the source map. We ship the source code, not the source code, but the bundled version to the browser, but we still want to open like the DevTools in the browser and be able to see the actual source code that was written. So you just put your source maps behind some auth zone, like firewall it. For example, in our company, we did that. We just put the source map in the internal space that, like, if you are not sitting from within the office, you don't have access to it. That's basically it. So if you are inside office, you open, you have it. No? Okay. You shouldn't work from home too often. Yeah, that's my problem. So I have a quick example. I don't think it's worth even getting there, but basically, yeah, like that's a dump example. I'm checking like if cookie includes secret, then I'm gonna get you this map. Otherwise, I'm gonna say no 404. That works. That works pretty well. I'm really interested in, like, not a lot of companies know about that, and totally not a lot of companies are using that. Are you using something like that? No? Okay. Yeah, that's true. That's a different thing to sell to the developers. Damn. Then we had the setup like that. So we, as I told you, we want to like have like no whatsoever source maps available in the browser, but we still want to log proper stack traces in our logging service. So you ship the static, like bundled version to the browser. In the browser, you have an error. Then you log an error to your like middleware server, which has access to the source maps. And given the stack from the browser, it can backtrace that. It can unveil the whole system, and then you already like pass the proper stack trace to the log service. So I have example on that one as well. Like this one uses the set of libraries that are available at stacktracejs.com. They are mostly from Mozilla. So, for example, there is a stacktrace GPS package. So it allows you, if you like define the proper caches for the source maps and for the source files, it allows you to like actually, given the stack trace, pinpoint to the proper one. So it works like that. You prepare the cache. You just read the file. Let me do that. Then you prepare the source cache. Just read the file. Then you prepare your GPS tracker. Offline true is actually needed because the stack trace GPS is intended to use both in Node.js or in the browser. So if it's used in the browser, it will actually download try at least download the source map. And then you just get your stack as just a string, right, in your server. You parse it with a separate package, error stack parser. Then you will get an array of stacks basically. Then for each stack you just get the proper one, gps.pinpoint, and then you have it like a beautiful one. I can quickly show you how it's gonna look. Is it 5? Yes, sweet. So this bundle does one thing. When it loads, it's gonna send a post request to our server, and it will, like as a body of that post, it will like append a stack of like some error, right? And if we go to the network, there is this /proper error call. So we are sending again the stack as just a string. and you will get back the proper file name, the unminified, the proper line, and the proper column. And if we go back to the index, we don't even have the index.js, you see, we have only like bundle. So yeah, I'm not even gonna show you that, but believe me, it's like the proper thing. Okay, so moving on, that was the 5th. Ooh, bonus. So then I thought, like, why stop there? Like, if we already have this cool engine to get for every given stack, error stack, we can actually backtrace it to the original file given the source maps. Why only have it on the Node.js when we can have it in the browser, right? So if we are now gonna do 6, cool. Sweet. So that's pretty simple app. The one thing that it does, every time I click on the body, it will generate a new error, right? Best production application ever. So I have this beautiful Chrome extension that when you like press it, it's gonna inject one script at the page called React Error Overlay. Somebody may be familiar with this package from other package called Create React App, right? When you do the dev mode in Create React App, you will get this nicely looking thing. So let's try it. I believe I clicked, maybe a second time. And then if I click the body, ooh, iframe, yeah, okay. That's live coding. Nice. So it happened, right? So what do we have here? We have here not only the like unminified version. So this is the original source file. You see, like it's only good stuff. It's only like 9 lines of code. You can see the compiled version here as well. But also, if you click in here, it will open the Visual Studio Code with the file that you were working in. Like, okay, cool, cool enough. Thank you. Yeah, so that is something really interesting. I'm gonna, like, this is just a proof of concept. It's not production ready yet. It's gonna be, because you're gonna use it on the production code. But it's not only thing that is cool about source maps. So we're using library called styled components in NordNet right now. And it's really hard to pinpoint, like you have the parts of the CSS, right? And it's hard to pinpoint which component actually did produce that. So it's coming. Like, as I shown you before, from the CSS you can have the source maps as well. And nobody said to you that you need to point that source map to the CSS file, right? You can point it to JavaScript file. You can point to JavaScript file to the actual line of code where you created your style components. So there is a PR for that already. It has some like conflicts right now. Nobody wants to tackle it. So if you have free time, you are welcome to do that. But it's coming, and it's nothing that's specific to the styled components. Pick any CSS and JS library. I believe they all have pretty much the same problems. So you can implement it yourself now that you know how the source maps are working. Then, pretty recently in the recent Node version, like they introduced the flag to like enable the source mapping natively. So then, if you are debugging that Node.js application, you will have, no matter how much Babel and TypeScript you have on top of that, you will have the same developer experience. Also, maybe some of you know this tool called Sentry. It's quite convenient. It allows you to do everything that we just spoke about, but as a service. I actually don't know if everything. I don't think they have this beautiful Chrome extension. I need to talk to them maybe. But yeah, that's it. Thank you. If you have any questions, I'm available. Telegram most, GitHub, Twitter, and you see like all of them are not standardized. And yeah, I know all of them were unavailable at different sites. Yeah, but thank you.
Thank you very much, Ivan.